Hi guys, Mr. Corzine here. I want to go through a few problems with you and do this activity together. There's something that I just wanted to make sure and point out to you as we solve more and more complex equations. What I want you guys to see is that lots of times these equations, they're like in disguise. They look more complicated than they really are. So just like it says down here below, sometimes it's just a simple two-step equation in disguise. I want to show you how no matter what the equation looks like, the algebraic equation looks like, as long as there's only one type of variable in it, even if it's on both sides of the equation, you can always get it down to being a two-step equation. You can simplify it. And so I'm going to start down here at the very bottom, and we'll work our way up to the top. And when that's done, I'm going to turn you loose to work on the backside on your own to figure those out. Okay? So I'm going to scroll down here to the bottom. The very first one is just a simple two-step equation. You guys know in a two-step equation that in a two-step equation, there's usually two things happening to the variable. It's either getting increased or decreased by something, but it's also getting multiplied or divided by another number. So here, I will first take care of any addition or subtraction by subtracting 8 on both sides. So now I have 4x is equal to 12. And then I will divide by 4 on both sides, and x equals 3. Ta-da! It's done. It's simplified. I do the opposite operation so that I can get my answer. All done. Well, now we're going to move up here. There are some times when they take an equation, a simple two-step equation, but they stretch it out. Okay. So they stretch it out in this disguise, and you have to combine like terms. So if you're able to combine like terms, you'll be able to get it to this two-step equation form. So let's look. If I have a 6x and a negative 2x right here, I'm going to bring those together because they're like terms, and I can like shorten this up. This becomes 4x. Now I also have a positive 5 and a positive 3. If I bring those two together, it makes a positive 8, and that equals 20. Now, I don't know if you realize this, but this equation now looks exactly like that one. I can subtract 8 on both sides, and that'll give me 12, 4x equals 12, and then I divide by 4 on both sides. Ta-da! X equals 3 once again. All right. Well, we're going to up the ante a little bit. I'm going to move up to the next one. And in this next one, let's see here. We're going to have to combine like terms. It's stretched out. So I see this 7x and this 3x all over here. And here's the equal sign. But on the other side, there's a variable on the other side as well. So I'm going to write variables on both sides. That's crazy. So let me see if I can get some of this stuff out of the way. Here we go. Let's try fixing this one. First of all, let's take our 7x and our 3x and combine that together to make 10x. All right. So now I've got 10x plus 8 is equal to 6x plus 20. Well, from here, I've combined all my like terms, but now I need to cancel out one of these variables on one side, one of these variable terms. So I think I'm going to go for the smaller one. I'm going to subtract 6x on both sides. That cancels out. And now my equation says, it just says 20 on the right-hand side. And on this side, 10x minus 6x makes 4x plus 8. Now, I don't know if you've ever seen this equation before, but if I keep scrolling back down, each one of these ended up just being 4x plus 8 equals 20, which might give you a clue on what's happening in the next equation. for this final equation, there's all kinds of stuff. We might have to combine like terms. You have to watch out for all this. Combine like terms. You also might have variables on both sides. But there's one other thing you have to watch out for, and that is you have to use the distributive property to first expand your equation and then start simplifying it. So in this problem, I've got 2 times 4x plus 10. So I'm going to do 2 times 4x, 2 times 10. That's going to give me 8x plus 20. And that's equal to, I'll change colors here, 4 times 3x and 4 times 2. That's going to give me 12x plus 8. Well, now I've got an equation that has variables on both sides. I think what I would like to do is I'd like to take care of this smaller variable term, subtract 8x on both sides. So this cancels out, and now I have 20 is equal to 4x plus 8. Now if I look down here, I scroll back down, you've seen 4x plus 8 equals 20. You've seen 4x plus 8 equals 20, and at the very bottom, and that's what we started with, 4x plus 8 equals 20. The other tricky part is that now it's backwards, but I still solve it the same way. Subtract 8 on both sides to get 4x equals 12. I divide by 3, or divide by 4 on both sides so that I get x equals 3. Did I? So if I went a little bit too fast for you, maybe you guys would want to watch this again. I am going to ask, here's your assignment, okay? Your assignment in class. Complete the back of your Incognito worksheet. Incognito worksheet. And then turn in. So before you leave the class, you're going to need to turn this in, guys. Look at the back. Take a look at that. There are several different levels of disguises here. You start at the bottom, work your way back up to the top. You'll turn that in before you leave. I hope that this helps you to see that these problems maybe aren't quite as complicated as they appear at first. All right, take care. We'll see you guys tomorrow.